Now that we're done with introduction, let us start with the fundamentals. So for this lesson, we're going to discuss fundamentals of graph, degree of a vertex, path and cycles, connectivity, trees and forest, bipartite graphs, construction, construction and mirrors, Euler tours. So we'll just discuss the fundamentals first. Kumbaga, yung mga basic concept about this graph theoretic object before we dive into each of them. Yeah. So we start with the fundamentals of graph. Let's have a recall of our definition of a graph. In this particular definition, we're defining a simple graph. A graph is a pair of objects VE of sets, where V is a non-empty set of objects called vertices, or sometimes we call it nodes or points, depending on a particular field of interest. Yan. Usually kasi sa engineering, ang tawag nila nodes. Kasi mga ano yan, mga representation of either electrical component or router when you're talking of networks. Yan. Kaya usually nodes ang representation nila. In math, usually it's a point, but in general, they are vertices. E is a two-element subsets of B called the edges. So this is an example of or a visual representation of a graph whose vertex set are the points A, B, C, D, E, and F, and the edges are the links between the points A, B, A, E, B, E, and F, C. Alright, when there is no confusion, we can disregard the subset notation. For example, the subset AB or the set containing the points A and B. So that's the edge AB. So for simplicity, we can just represent that as AB. So pag walang confusion, i-represent lang natin yung subset as the two-letter word AB. So that means it's the subset containing A and B, which represent the edge connecting A and B. Alright. On the same manner, we have the set containing AE. So that's the edge AE. AB is the set containing A and B, and FC is the set containing F and C. Alright? So, if there are no confusion, kung hindi naman naka-confuse yung ganung manner, pero ultimately, kung naka-confuse, we go back to the subset notation. Alright. For a graph G, the order of G is the number of vertices in G. So, that's the size of V. Or rather, I will not use the term size for the number of vertices kasi baka malito. So the cardinality of the set V. Yan. So the number of elements of V is the order of V, while the number of edges is the size of P. A null graph is a trivial graph na walang vertices. So null, wala tayong pinag-uusapan. Trivial graph is a graph with either 1 or 0 vertices. Yan. So trivial yung mga graph na wala kang graph, which is a null graph, or meron kang vertex pero isa lang. So wala kang edge. Now, in general, pag walang edge pero maraming vertex, that's an empty graph. So you can have a graph with numerous vertices pero if it doesn't have any edge, okay? So there's no connection between them, so we're not talking of a graph. That's an empty graph. Of course, empty graphs are of no interest to us. But for the purpose of discussion, sometimes may mga example tayo na kakailanganin natin yung mga null graph, trivial graph, empty graph, and so on. Okay. We've already discussed some taxonomy, pero dadagdagan lang natin ng konti. Again, V is incident with an edge if V is an endpoint of that edge. Meaning, as a set, yung V ay element ng subset na E. Di ba? E is a set, di ba? So parang kung titingnan natin siya as a set, meron ka dapat makuhang edge sa graph mo na isa dun yung V as element ng edge na yon. So V is in the set VU where U is one of the endpoints of E. Okay? So an endpoint of an edge is the incidence means the edge is at that endpoint. Yun lang ibig sabihin ng incident. E of V is the set of all edges. Kaya madaling tanda kasi E. Edges that are incident at V. So, edges that are incident of V. So, kung meron kang V, lahat ng edge na naka-incident sa kanya. So, let's say this is F, G, H. So, lahat ng tumatama dun sa V or ang endpoint ay V. Lahat yon pag pinagsama-sama mo, that's your E of V. The points that are incident to V. Rather, the edges that are incident to V. Now, if U and V are adjacent, then UV is an edge. So, meaning U and V are endpoints of an edge. So, adjacency of two vertices means there's an edge between them. It is connected by an edge. Isang edge lang, yung nakakonect sa kanila. Alright. Now, if we get all those endpoints other than V, yung mga nasa kabila. So, for example, this is your V, tapos meron yung mga points dito na U1, U2, U3. So, lahat yon yung mga nasa kabilang endpoint ng mga incident at V, ang tawag naman doon ay neighbors ni V. So, the set of all vertices that are adjacent with the vertex V. So, again, if you share a common edge, then you are adjacent vertices. Then you get all vertices that are adjacent to V. So, that's N of B. N for neighbors. Napakadaling tandaan. Neighbors, N. Alright? So, again, those are the points that are adjacent to V. We're talking of simple graph. So, hindi mo pwedeng neighbor ang sarili mo kasi wala tayong loop. Wala tayong mga parallel edges. Simple yung graph natin. A graph is complete if all the vertices are pairwise adjacent. Ibig sabihin, kada isang vertex nakakonect sa lahat ng iba pang vertex. So, that's a complete graph. Meaning, lahat ng point, neighbors ng lahat ng point. So, each point, ang mga neighbor niya, the rest of the points. Yan. A complete graph on vertices, on n vertices, is usually denoted by Kn. So, K sub n. Hindi na C, kasi yung C ay nakuha na ng cycle, kaya K na ang representation. So, later, we'll discuss about a cycle. So, yun yung C sub n. So, pag K sub n, that's a complete graph on n vertices. For example, you have two vertices. So, if you connect them with an edge, that's a complete graph, K2, kasi dalawa yung vertices. If you have three vertices and you connect all of them, that's K3. Ayan. If you have four vertices, you connect all of the vertices to each other. Ayan. So that's K4 and so on. Alright? So each vertices is connected to any other vertices. Alright. E and F, so this time adjacency between two edges. Two edges are adjacent if they have a common vertex. Kanina, two vertices are adjacent if they share a common edge. So this time, two edges are adjacent if they share a common vertex. So, ang dalawang vertex magkapit-bahay pag may common edge sila. Ang dalawang edge magkapit-bahay pag may common vertex sila. Pero we don't say na ang edge at ang vertex magkapit-bahay. So, we don't say na magkapit-bahay ang E tsaka ang V. Ang edge tsaka ang vertex. Ang pagka edge at vertex ng relationship, either incidence or not. Incidence, ibig sabihin, tumatama yung E sa vertex. Alright? So, pag magkapit-bahay, ibig sabihin, pinagdidikit lang ng common vertex pagka edge ang pinag-uusapan, common edge pag vertex ang pinag-uusapan. Alright. Just to avoid the misconception between adjacency, between edges and points. Okay, so a set of vertices or edges is independent if no two of its elements are adjacent. So kung walang magkapit-bahay dun sa mga points mo, then independent yung mga points. Kung walang magkapit-bahay dun sa mga edges mo, then independent yung mga edges. Okay? Alright, let's have an example. This is the same graph as I've shown a while ago. So we have the vertices on the graph on the vertices A, B, C, D, and F, where the edges are AB, AE, BE, and CF. So A is incident with AE and AB. So the vertex A is incident with the edges AE and AB, because vertex A is contained in edges AE, and the same with edge AB. A and E are the endpoints of edge AE. Alright. A is adjacent to E. So, pag sinabi mong adjacent, dapat point to point or edge to edge. So, yung A tsaka yung E adjacent since they share a common edge, yung edge AE. So, the endpoints of an edge are always adjacent with each other. E of A. So, all the edges incident at A. So, all the edges incident are AE and AB. So, you have the edge AE and AB. No other. N of A, neighbors of A. So, all the vertices that are adjacent with A. So, yun yung, kumbaga, yun yung nasa kabilang endpoint ng mga to. Yan. So, magka-relate ang E of A sa N of A. So, ang E, edges. Ang N, neighbor. So, pag E of A ang hinahanap, ang isasagot dapat mga edges. Pag N of A ang hinahanap, dapat ang sagot mga vertices, mga neighbors. So, ano ba yung mga nasa kabilang edges? E de E tsaka B. Yun, E tsaka B. So, kung ito yung A, yung nasa kabila is yung E, tsaka yung B. So, yun yung mga neighbor niya. Lahat ng nakakonect sa kanya. Though, malapit ang F, pero hindi niya neighbor yon kasi again, pwede naman nating i-redraw yung graph na malayo yung F. So, we don't look at the neighbors being geometrically near. So, laging ang pag-treat ng neighbor with respect to edge. Alright. Now, some relationship or relations rather between graphs. So, let's say we have a graph VE and another graph V prime E prime. So, two different graphs. So, we say that two graphs are isomorphic if there's a bijection between its vertices such that XY is in G if and only if the image of these vertices is also an edge in G prime. Right. So, ano ibig sabihin ng isomorphism? Ibig sabihin ng isomorphism, pwede mong i-relate, may one-to-one correspondence between the vertices. Ibig sabihin, kung gaano karami yung vertex V, ganoon din dapat karami yung vertex V prime. Of course, similarly, dapat ganoon din karami yung edges, and at the same time, kung ano yung corresponding edge sa graph G, dapat yun din yung corresponding edges sa graph G prime. So, ibig sabihin, pag ang XY ay edge sa G, dapat yung image nila edge din sa G prime. So, yun yung ibig sabihin ng isomorphism. Okay, let's have an example. These two graphs are actually isomorphic. Yan, yung dalawang graph na yan. Parang mahirap imagine na isomorphic sila. But actually, it's easy to imagine. Look at this graph. Kung yung part na to ng C, ito, i-redraw mo doon. So that will become something like this. Diba? Ililipat mo doon yung C. Diba? Parang pinlip mo yung position. That's exactly this one. Right? Parang pareho sila, di ba? So, these are isomorphic. So, that should give us an idea kung ano yung bijection na hinahanap natin. So, if you decide your bijection, si A, so alin yung kapartner ni A doon sa graph? So, ito si A. So, dapat siya yung maging 1. So, we map A to 1. 1-to-1 correspondence meaning may ka-correspond na vertex yung unang graph sa pangalawang graph. So, we're mapping the vertices. So, itong B, ito yung B. So, ito yung kamap niya, yung 2. So, B should be mapped to 2. Tapos, C is this one. So, ito yung C. So, C is mapped to 4. And D is 3. Siyempre, yun na lang natitira. So that's a one-to-one correspondence. Now, how do you know that it's an isomorphism between the graph? You should be able to identify the edges on G to be the edges on G prime. So, pag ang AB ay edges sa V, dapat yung image ng AB ay edges din sa V prime. So, let's see. Ang mga edges sa V ay AB, AD, BD, BC, saka CD. So, ito lahat yan. AB, AD, BC, BD, CD. So, anong image ng AB? Ang image ng A ay 1, ang image ng B ay 2. So, this AB is, ang image niya should be 1, 2. So, let's check, is 1, 2 an edge? So, ito yung 1, 2. 1, 2. So, okay tayo sa 1, 2. Ang AD, ang image ng A ay 1, ang image ng B ay 3. So, ang 1, 3 ba ay edge sa V prime? So, ito siya. Ang BC ay, ang B ay 2, ang C ay 4. So, this is 2, 4. This one. Nga? So, ito yung BD. Ito yung BD. Right? Tapos, ito yung 2, 4. BD. BC pala, sorry. BC pala yung kinuha natin. Sorry. My bad. Ito pala yung BC. Ito yung BC. Tapos, ito yung 2, 4. Which is correct naman. Yun naman talaga yung kapartner natin, di ba? BD, so this time B is 2, B is 3. So that is the edge 2, 3. And then CD is 4, 3. So this is the edge 4, 3. So tama. Lahat ng edge sa V prime ay corresponding edges from G. Or from V rather, yung vertex set ng G. Okay? So indeed, in our example, G is isomorphic to G prime. Because it satisfied the condition that we were able to find a one-to-one correspondence between the vertices and such that the corresponding edge in G is an edge in V prime. Ang edge sa G ay edge din sa ay ang corresponding edge sa G prime. Okay? This should be edge in G. Kasi V is vertices. It should be edge in G prime. Just to correct the terminology. Alright. Question. Wala pong tanong. Okay. So, how do we combine graphs? Okay. So, these are graph operation. So, we have graph union. The graph union is simply the union between the vertices and the edges. So, if you have two graphs, the union of G and union of G prime is simply you get the union of the vertices and the union of the edges. So, that's the graph union. Similarly, graph intersection are the intersections of their vertices and their edges. The graph difference is the difference between the vertices and the difference between the edges. Meaning, that's complement as a set complement. You get the relative complement of B with respect to B prime and the relative complement of E with respect to E prime. So that's the graph difference. Meaning, you just remove the vertices in V that are in V prime. So, di ba in set theory, pag sinabi mong V except V prime, that's all the vertices V in your capital V and not in V prime. So, ibig sabihin, pagka yung vertex ay nasa V prime, aalisin mo yan. Aalisin mo yan. Now, when you remove a vertex, it should imply na lahat ng mga incident na edges doon mawawala. Kasi syempre hindi pwedeng maiwan yung vertex. Halimbawa, ni-remove mo yung vertex. Yan. For sake of discussion, let's say this is 1, 2, 3. Pag ni-remove mo yung vertex na to, tinanggal mo yan. Dapat mawawala din yung edge 1, 2, tsaka 1, 3. Bakit? Kasi wala ka ng vertex 1 eh. Alright? Pero, Pag ang niremove mo yung edge, hindi mo kailangan tanggalin yung vertex. Tatanggalin mo lang naman yung edge eh. Pero yung vertex, pwedeng maiwan doon. Okay po, may iwan pa rin yung vertex pag edge ang tinanggal. Alright, so ulitin ko. Pag nagtatanggal ka ng vertex, lahat ng edge na incident doon, natatanggal din, nawawala din. But if you remove an edge, the vertex remains. Nandun pa rin yung vertex. Kasi baka nakakonect pa siya sa iba pa eh. Diba? Ang tinanggal mo lang naman yung edge 1, 2. But the vertex should stay unless you remove the vertex as well. So parang pag vertex ang tinanggal, lahat ng kasama ng vertex tanggal. Pag edge ang tinanggal, parang tinanggal mo lang yung connection between the two, pero nag-i-exist pa rin yung object. For example, in-unfriend mo sa Facebook, in-unfriend mo yung isang tao, kayong dalawa, user pa rin kayo ng Facebook. So part pa rin kayo ng network ng Facebook. Pero wala nang edge between the two of you. So yun yung ibig sabihin ng tatanggalin mo yung link between them, tatanggalin mo yung edge. Pero pag tinanggal mo, halimbawa ikaw, dinilit mo yung user account mo, right? So mawawala ka na doon sa network ng Facebook. So lahat ng ka-friend mo sa Facebook, syempre mawawala na rin ng connection sa'yo. So mawawala rin yung mga edge na yon. Kasi nga, wala na yung edge connecting those edges. Vertex. Wala na yung vertex connecting those edges. Malinaw po ba yun? Pag nagre-remove. Okay? So usually doon nagkakaproblema yung students eh. Question po? Okay, wala naman ito. Alright, let's have an example. Let's say we have here G is the graph on vertex 1, 2, 3, 4, 5 such that the edges are 1, 2, 2, 4, 2, 3, 3, 5, and 4, 5. Alright. Now, the other graph G prime has vertices 3, 4, 5, 6. So these objects 3, 4, and 5 are the same as the object 3, 4, and 5 on G. So ganun yung idea. We're talking of just same universe of objects. So these points 3, 4, and 5 are the same as the points 3, 4, and 5 in G. Alright. Now, on G prime, the edges are 3, 4, 4, 5, 3, 5, 4, 6, and 5, 6. Alright. So these are the set representation, and these are the visual representation. Again, there could be any other representation of the same graph. Kasi nga, di ba, sabi natin, pwede mong iba-ibahin yung posisyon. So, do not limit your imagination on the physical restriction of how we draw the graph. So, physically boundless ang graph natin. Geometrically boundless. Kahit saan pwede mapunta ang point. Basta mahalaga, pag meron kang connection between the two, for example, 1 and 2, the edge 1 to exist, then wherever you put 1, wherever you put 2, there must be a line connecting them. There must be a link connecting them. Kung kahit saan man nakapwesto yan. So, yun yung sinasabi natin topographically the same. Same set of edges, same set of vertices, pero pwedeng visually different. Okay? Kasi pwede ko namang iba-iba yung pwesto di ba? Pwedeng, halimbawa, ganito. Nandito yung 2, nandito yung 4, nandito yung 3, nandito yung 5, nandito yung 1. Iba-iba na yung pagkakapwesto, pero kung ang magiging connection niya ay the same, 1 nakakonect pa rin sa 2, 2 nakakonect sa 3, 2 nakakonect sa 4, 3 nakakonect sa 5, 4 nakakonect sa 5. That's still the same graph. They're still isomorphic. Diba? Nire-arrange ko lang naman. Nire-request ko lang yung mga 3, 4. Pero, the graph are essentially the same because of this representation. Sila pa rin yung vertices, sila pa rin yung edges. So, topographically the same, but visually different. So, again, do not limit your imagination with the constraint of geometry. So, kailangan lagi mong nakikita yung mga topographically the same graph. Kahit na iba yung pagkakadrawing. Alright, anyway. So, let's find the union of the two graphs. So, How do we get the union? We simply get the union of the vertices and then the union of the edges. So this is the union of the vertices, 1, 2, 3, 4, 5, 6. And then you just draw the edges, the union of the edges. So on the first graph, I have an edge on 1, 2, right? On 2, 4, on 2, 3, on 3, 5, on 4, 5, on 5, 6, and 4, 5. Sorry. Kung yung graph G pa lang pinag-uusapan, yan pa lang yung graph G. And then you union it with the edges in G prime. So meron tayong 3, 4, 3, 5 andito na, 4, 5, 4, 6, and 5, 6. Alright? So that's your union. Now, what's the intersection? You get the common vertices. So what's the common vertices here? So the common vertices are just 3, 4, and 5. Yun lang yung common na vertices. So you remove yung mga hindi common. Dito common, dito common. Alright. And then, you get the common edges. So ang common edge lang naman ay yung edge ng 3, 5, tsaka 4, 5. So that becomes 3, 5, tsaka 4, 5. So that's your intersection of the graph. Common vertices and common edges. Alright? Question so far? Wala. Okay. Now, how about the difference? So on the difference, what you do is you remove all the vertices in V prime and all the edges in E prime that are in our graph G. So parang meron kang graph G, alisin mo lahat ng nakay G prime. Yung matitira, that will be your G minus G prime. Okay, so we start with G. So ito si G. Right? And then you remove everything that belongs to G prime. So of course, we need to remove 3, right? We need to remove 4 and 5 because all of them belongs to G prime. We also need to remove this edge because 4 is no longer on the difference kasi ini-remove na natin yung vertex 4. Also, 6 is not in G on the first place, so wala din siya sa G minus G prime. So ano lang natira? Ang natira na lang are the vertices 1, 2, and the edge connecting them. So that's your G minus G prime. Dahil lang, di ba? Question. Okay. Now, if the graph is not available, you can use the set to get the same effect. So, for example, you get the union of V and V prime. V should be V prime. Sorry. Yes. B prime, B prime. Ano po yan? Okay. So, similarly, pwede mo rin naman gawin yan using just the set. So, for example, you want to get G intersection G prime. So, ano magiging vertex mo? So, the vertex will be, the vertex of G intersection G prime will be the intersection of the vertices. So, 1, 2, 3, 4, and 5, 3, 4, 5, and 6. So, the intersection is 3, 4, 5. Right? Which is the same as our graph. 3, 4, 5. Alright. So, what are the edges? The intersection of the edges here. So, what are the common edges on our E and E prime? So, those are precisely the edges 3, 5, and 4, 5. 3, 5, and 4, 5. So that's your intersection. That's the edge of G intersection G prime. Right? Now here, we want to get the vertex of G minus G prime. So all you need to do is to get the difference between the set V and V prime. So 1, 2, 3, 4, 5 minus the elements 3, 4, 5, and 6. So you remove 3, 4, and 5, you reduce with 1, 2. And then the edges will be any edges on E prime removed on E. So, meaning, i-remove mo yung intersection. So, mariremove yung 3 tsaka yung 3, 5, and 4, 5. Now, how about 2, 4? So, what will happen? Ala naman siya dito sa intersection. No, although 3, 4 is not in E prime, kasi E prime yung tinatanggal natin, we no longer have an edge 4. Right? So, since we no longer have an edge 4, then this will be removed as well. So, ang matitira na lang, 1, 2, tsaka, the same as 2, 3. Wala na rin tayong edge na 3. So, ang matitira na lang, yung 1, 2 na lang ang natira. Kaya yun lang yung natirang edge. 1, 2 na lang. Alright? Question? So whether you're working on its graphical representation or you're working in its set representation, pareho lang. Okay, pareho lang. So, meaning kung alin yung mas advantageous sa inyo. Of course, if we're talking of devising an algorithm so that we can compute properly the output of these operations of set, then ang kailangan natin yung set representation. Because it's really hard to represent a graph visually in a computer. So usually pagka ini-encode natin ang mga graph, especially where we're trying to find properties of graph, hindi natin sinisave sa computer yung graphical representation because that will be really hard and inconvenient for us to do that. Ang sinisave talaga natin ay yung set. Sinisave natin yung elements 1, 2, 3, 4, 5. There's a way for us to save that as a set in a computer, and also the edges as a subset 1, 2, 2, 3, and so on. So yun yung mga sinisave natin. Now another program will be used to have a visual representation for that. For example, pag nakita niya sa set representation that there's an edge 2, 3, then on our visual representation, magko-connect lang siya ng line on vertex 2 and vertex 3. Alright? Well, that's the computer programming side of graph theory. Yan. How we represent it or how we save the data as graph in a computer as graph. Yan. So usually ganun yung nangyayari sa data science. All right. Now, I will leave as an exercise for you to list down all the vertices and the edges of the union, the intersection, and the difference. So all you need to do is to list down yung mga set or mga vertices and sets doon sa visual representation natin. Right? But it will be interesting to note as well kung hindi mo titingnan yung visual representation pero bubuin mo yung mga set na to using these two sets, using just these two sets. Kung sila yung gagamitin mo without looking. Try to do it without looking at the graphical representation. Yes, graphical representation helps us to imagine what happens to our graph, but sometimes when your graph is a little complicated or has numerous vertices, imagining the graph become disadvantageous. Nagiging mas pahirap pa kung tinatry mong imagine mo na yung graph kaysa i-represent yung graph in the set. So it's a good practice to compute for these sets without looking at its graphical representation and just computing the graph given the following informations on set. This set information, the set representation of graph. So, check nyo na lang. Kunin nyo muna, tapos i-check nyo kung tama ba na yun yung mga edges, yun yung mga vertices na matitira or na mapoproduce. Alright. Question on operations. Wala naman. So, more relations on graph. So, we have what we call a subgraph. So, G is a subgraph of G prime which we denote by parang subset notation. Because really it can be viewed as a subset. So if we look at it in set representation, a subgraph of G prime is a graph G where the vertices of G and edges of G are subsets of the vertices and edges of G prime respectively. So the vertex set is a subset of V prime and the edge set is a subset of E prime. So that's what we mean by a subgraph. Now, if G is a subgraph of G prime but they are not equal, so we call them proper subgraph. So para lang ding proper subset. So meaning, G may have fewer vertices or fewer edges than G prime. Parang mas konti yung vertices niya or mas konti yung edges niya. Alright, now G is an induced subgraph of G prime if, this is what happened, G is a subgraph, pero an induced subgraph means G contains all the edges xy of E prime with xy being vertex of G. Okay, pero parang medyo nakakahilo yung definition, no? Sige, mamaya sa example, babalikan natin yan. Pero, ganito lang yon. G contains lahat ng edges ng E prime. So, E prime yung mas malaking graph. So, lahat ng edges ni E prime, basta't ang XY ay vertex sa mas maliit na graph. Alright? So, pag nakakita ka ng dalawang vertex sa G, dapat yung kung may edge doon sa mas malaking graph, dapat edge din yon ng mas maliit na graph. Yun ang ibig sabihin. So, halimbawa, meron kang XY na nakay V. Pero siyempre, subgraph kasi siya ni V prime, di ba? So, pag ang X at Y ay edge ni V prime, ni G prime, dapat edge din siya ni V. Okay? So, kukuha ka ng dalawang vertex ni G, titingnan mo kung yung vertices na yon ay nagpo-form ng edge ni V prime. Pag nagpo-form siya ng edge ni V prime, dapat edge din siya sa G. Yan, okay? Again, mamaya, pag hindi pa rin naiintindihan, mamaya sa drawing, papakita natin. In this case, we say that V induces or span G in G prime. So, G is a spanning subgraph of G prime. If G is a subgraph of G prime, and V spans all of G prime. So, paano mo sinasabing V spans all of G prime? Ibig sabihin, yung mga vertices ni V, pag tiningnan mo lahat ng edges doon ni G prime, nandun lahat yung edges ni G prime. Nai-span mo lahat ng edges ni G prime. Alright, in short, ganito. Pag kinuha mo yung span ng mga vertices, let's say U lang. So, let's say U is a subset of the vertices. So, kukunin mo yung span niya. So, the graph on U, the span of U is the graph on U whose edges are precisely the edges of G with both ends in U. Sige, drawing na natin para hindi nakakalito. Alright. This is an example. So, let's say this is G prime. The graph containing the vertices 1, 2, 3, 4, and 5 and edges. So, ang mga edges niya ay 1, 2, 1, 5, 2, 5, 1, 3, 3, 5, 4, 5, 2, 4, and 3, 4. So, meron tayong 1, 2, 3, 4, 5, 6, 7, 8 edges ng G prime. 5 vertices, 8 edges. Alright. Now, G on the other hand is the graph 1, 2, 3, 4. Pero just connecting 1, 2, 1, 3, 2, 4, and 3, 4. On the other hand, H is 1, 2, 3, 4, 5 ang vertices. But the edges are 1, 2, 1, 3, 3, 4, 2, 4, and 3, 5. Okay. So, visually, kaya na nating sabihin, G and H are subgraph. Bakit? Kasi yung mga vertices at saka yung mga edges, subsets ng mga vertices at edges ni G prime. So, that's clear. Now, on the other hand, G is an induced subgraph of G prime. Okay, so ito yung ibig sabihin ng induced subgraph. Pag kumuha ka ng dalawang vertex ni V, so si G, yun yung subgraph, yun yung mas maliit na graph. Si G prime yung mas malaking graph. Kumuha ka ng dalawang element, let's say 1, 2. So, titingnan mo yung 1, 2 sa G prime, sa mas malaking graph. Yung 1, 2 ba, edge ni G prime? pag yung 1 to edge ni G prime, dapat edge din siya ni G. Which is in this case, true. O, yan. O, kuha ka pa. 1, 4. So, yung 1, 4, element ng V. Kukuha mo ka muna ng dalawang vertex sa G. Tapos, titingnan mo siya sa mas malaking graph. Yung bang 1, 4 ay edge sa G prime? Pag edge siya sa G prime, dapat edge din siya sa G. Eh, hindi naman siya edge sa G prime. Wala namang 1, 4 sa G prime. So dapat hindi rin siya edge sa G. Okay, ganun lang po. So, lahat ng vertices sa V, sa maliit na graph, na nagfo-form ng edge sa mas malaking graph, dapat nagfo-form din ng edge sa mas maliit na graph. So, ang mga edge lang naman dito sa malaking graph na nafo-form ng mga vertices ng maliit na graph ay 1, 4, 2, 4, 3, 4, and 1, 3, which are precisely the graph G. Okay. Now, yung H, hindi siya induce. Hindi siya induce. Bakit? Kasi makakakita tayo ng dalawang vertex ni H na meron siyang edge sa G prime pero wala siyang edge sa H. So, may vertex yung mas maliit na graph na pag tinignan mo sa mas malaking graph, may edge doon, pero yung edge na yon wala doon sa mas maliit na graph. Alin yon? For example, 2, 5. 2, 5 are two different points in H. Meron kang 2, meron kang 5. So, pag tinignan mo siya sa G prime, merong edge yung 2, 5. Pero walang edge sa H na 2, 5. So, hindi induced graph. Hindi induced subgraph yung H. Alright? Kasi, may mga part siya na nag-i-exist yung vertex na yon nung dalawang edge niya sa G prime, pero wala yung edge na yun sa kanya. Okay? So, ganito lang yan. Kung isipin natin, meron kang dalawang user ng Facebook sa H. Pero yung dalawang user na yun sa Facebook, magka-friend siya sa G prime, pero hindi sila friend sa H. Ayun. Baka mas madaling intindihin. So, hindi yun induced subgraph. Kasi meron kang dalawang vertex na magka-connecta sa G prime, pero hindi magka-connecta sa'yo. Okay na. So, subgraph ka, yes, yung H subgraph, pero hindi ka induced subgraph sa G prime. Ng G prime lalo. So, H is not an induced subgraph of G prime since we can find two vertices in H that connects an edge in G prime but does not have an edge on G. There is an edge of G prime whose endpoints are in H, but that edge is not in H. That edge is not in H. Pero yung endpoints niya nasa H. Yung edge lang yung wala. So, kumbaga, kulang si H. Kulang si H. Yun yung ibig sabihin ng induce. Alright. Now, paano naman mag-span? Paano mag-span ng subgraph? Okay, ganito mag-span ng subgraph. So, let's take for example, kunin natin yung span ng 1, 2, 3. Yung vertices 1, 2, 5, rather. 1, 2, 5. So, ito yung vertices 1, 2, 5 ng G prime. So, ang gagawin mo lang, kukunin mo lahat ng edges ni G prime na na-form using vertices 1, 3, and 5. 1, 2, and 5 rather. So, lahat ng edges, which are these edges, 1, 2, 1, 5, 2, 5. So, this subgraph, 1, 2, 5, is the span of the vertices 1, 2, 5. Parang nire-redraw mo yung graph mo, pero all of those edges lang that is incident to your vertices 1, 2, and 5. So, in this case, yung G ay span ng 1, 2, 3, and 4. So, dun sa G prime, kukunin mo yung vertices 1, 2, 3, and 4, tapos i-form mo lahat ng edges na nagko-connect ng mga yon. So, mapo-form mo yung G. So, yung G, siya yung span ng 1, 2, 3, and 4. This is actually the span of the set 1, 2, 3, and 4. Alright, so ganun kumuha ng span. Okay, question po. Sige, siguro, naintindihan naman, no? Madali naman intindihan. Alright, more operations on the graph. For a graph G, if U is any set of vertices, usually U is a subset of V, then G minus U is the span of the vertices B minus U obtained from G by deleting all the vertices in V intersection U and their incident edges. So, para lang din tong yung kanina na difference ng dalawang graph. Pero this time kasi, parang para magkaroon ng meaning yung G minus U as a set of vertices. Kasi kanina, graph minus a graph. This time, graph minus set of vertices. So, itong set of vertices, ang nangyayari lang, kinukuha mo lang, tinatanggal mo lang yung graph, subgraph ni G na nai-span nung U. So, tatanggalin mo lahat ng subgraph ni G na nai-span ni U. So, yan yung G minus U. Ibig sabihin, lahat ng vertex tsaka lahat ng edges na nakakonect kay U. Tatanggalin mo. Yung matitira, yun yung G minus U. Alright. For simplicity, pag isa lang yung laman ng U, singleton lang siya, usually nira-write natin siya as G minus the element V. So, ibig sabihin, may meaning din yung G minus a vertex. So, kanina, G minus a graph. Yung G minus U, G minus subsets of vertices. Yung G minus a vertex, ibig sabihin, isang vertex lang yung tatanggalin mo. Now, if F is a subset of the edges, so this ay na mga edges. So, ang G minus edges naman ay ikikip mo pa rin yung V, pero tatanggalin mo lang yung mga edges na nasa F. So, kamukha lang din nung kanina, mariretain yung V. So, parang pag nagtanggal ka ng V, mas maraming nawawala kaysa pag tinanggal mo lang yung edge. So, when you're removing an edge, you don't need to remove the vertices. But when you remove the vertices, you remove all that is incident to that vertices. Pag nakakalimutan niyo, ibig sabihin, lagi niyong alalahanin yung Facebook friends. Okay? Pag tinanggal mo yung edge between two friends, existing pa rin sila as user ng Facebook, na wala lang yung connection between them, yung friendship between them. Pero when you remove a vertex, meaning a specific user, i-delete mo na sa Facebook, of course, lahat ng connection niya sa Facebook, mawawala na rin. So, lahat din ng edges, mawawala. Okay. Here's a visual example. Let's say we have this set yan. So, yung graph natin is the graph containing the vertices 1, 2, 3, 4, and 5, 4, 5, and 6 with edges 1, 2, 2, 3, 1, 3, 1, 6, 3, 4, 6, 4, 6, 5, 4, 5. Yan. Yung pagkakasulat ko kanina ng 6, 4, 4, 6, pero yung 4, 6 saka 6, 4, pareho lang yun ha. As a simple graph, 4, 6 is equal to 6, 4. Kasi subset yan eh. Kumbaga, sinisimplify lang natin yung sulat, pero remember, that's a set containing 4 and 6. So this is a set containing 6 and 4. So as a set, equal lang sila. Ha? Baka kasi nalilito kayo, sir, kanina sabi mo, 6, 4, 46 yung nakasulat. So huwag yung basahin na 46. Malilito kayo pag 46 binasa nyo. So, ito yung classical example na kung convenient lang. So, if you can imagine, paano kung meron tayong 12 vertices? Hindi na pwede yung gantong pagsulat pag 12 vertices. Kasi pag sinulat mo, halimbawa, just to make my point, halimbawa, meron kang vertex 10, tsaka vertex 12. So, pag tinonect mo yung dalawa na yan, magkakaroon ka ng edge 10, 12. So, ngayon, ang tanong, yan ba ay edge 10, 12? O baka mamaya meron kang edge na 101 at saka vertex 101 tsaka 2. So, paano may susulat yung vertex 101 tsaka 2? May 1012. So, may confusion na. Dalawang magkaibang edge, pareho ng representation. Well, in that case, kasi, hindi na pwede yung notation natin. Dapat isusulat mo na siya strictly as a set. 10, 12. 10, 12. Hindi ko masulat yan. Alright. Now, this is 101, 12. Okay? To avoid confusion. Again, Pag less than 10, okay yung representation natin na to, pero pagka more than 10 ang mga edges, hindi na okay yung representation natin. So, kung convenient lang, tsaka natin gagamitin yung ganitong representation. Okay po? Kung convenient lang. Question. Alright. In our case, it's still convenient. Now, so, tanong, what is G minus 1, 2? Okay. In our representation, this set is not an edge. These are vertices. Yan. Vertices. In our representation, these are vertices. Kasi sa representation natin, ito yung mga edges. Ayan para malinaw tayo. Pagka double digit sa representation na to, edges yan. Edges. Alright. Pag isa lang, vertex yon. What is G minus the vertex 1 and 2, vertices 1 and 2. So, anong gagawin mo? So, all you need to do is to remove all the vertices 1 and 2 on G. So, this is our G. All you need to do is to remove 1 and all that are incident to 1. So, wala na yung 1. And remove 2 and all that is incident to 2. Okay. So, ang matitira, yun yung G minus 1, 2. So, that's G minus 1, 2. Now, if you remove an edge, on the other hand, edge lang yung tatanggalin mo. So, you remove edge 1, 3, this edge, and edge 4, 6, this edge. So, ang natira, G minus 1, 3, 4, 6. Now, you add an edge, meaning magdadagdag ka ng edge. Right? So, idodrawing mo yung edge. Okay, so let's draw edge. The additional edge is 1, 4. So, this edge, and 3, 6 to this edge. Okay? So, that's how we add an edge. Question?
Lab.
Okay. Hindi na naman. Complement. The complement denoted by G bar of G is the graph on V with edge set B squared minus E. Ano ibig sabihin ng B squared? Yung B squared, ang ibig sabihin niyan, yung lahat ng possible edges in a graph. Tanggalin mo lahat ng edges E. Yung matitira, yun yung complement. Okay? Meaning, if XY is an edge in G, then XY is not an edge. Wait, this is G bar. This should be G bar. Mali yung aking notation. Let me erase this one. Ayaw ma-erase. Okay. And replace it with G bar. So, if XY is an edge in G bar, dapat hindi siya edge sa G. Pag yung XY ay edge sa G, dapat hindi siya edge sa G bar, sa complement. So, complement, lahat ng wala kay G, na kay G bar. Lahat ng wala kay G bar, na kay G. Yan lang kasimple. Alright? Okay. That's the complement. Later, mag-drawing tayo ng complement. Now, on the other hand, ang line graph naman is the graph on E. So, this time, yung E, gagawin mong point. So, it's another graph. It's a different graph from G. So, the new vertex set is the edges and two vertices, how do you call this? Two edge in E will be adjacent in the line graph if these vertices, or rather, these edges in E are adjacent in G. So, may dalawa na kasi tayong graph na pinag-uusapan. Meron tayong G, tsaka LG. Okay. So, ano ang mga vertices ni L? Ang mga vertices ni L ay mga edges in G. Okay. So, paano mo masasabi na ang edges in L ay adjacent? Kumuha ka ng dalawang L edge ni G. Kung adjacent sila sa G, adjacent yon sa L. Okay po? So, ibang graph siya na ang mga vertices niya ay mga edges in G. Pag yung dalawang edge ni G ay adjacent, adjacent yung dalawa na yon sa L of G. Okay. Pata example, para malinaw. Medyo nakakahilo yan pag walang visual representation. Alright. Now, this is the same G as we had before. Alright. Let's get the complement. So, as a visually represented graph, ito yung complement. So, you have the same set of vertices. So, that's already clear. Your set of vertices are the same. So, ano ang magkaiba? Your set of edges. Ang complement ay lahat ng edge na mafo-form using those vertices na wala sa G. So, halimbawa, ang 1, 6 ay edge sa G. So, hindi na siya edge sa complement. So, hanapin mo lang lahat ng edge na hindi na form ni G. For example, 1, 5. 1, 5, walang edge sa G. So, sa complement, magiging edge siya. Wait lang. Let me just change the color of the pen. Alright, 1, 5 is an edge. 1, 4 is also an edge. Right? How about 1, 2? Is this an edge in the complement?
Hindi po.
Hindi. 1, 3.
Hindi po.
So, okay na tayo sa 1. So, punta tayo sa 2. How about 2, 1? Yes or no? Kung nasa complement, 2, 1.
No po.
2, 6.
Hindi po.
Yes,
Yes,
po.
it should be in the complement. Right? So, 2, 6, 2, 5.
Yes po.
2, 5, yes. 2, 4, yes. Nakukuha po ba? Tapos na ba? Okay na? Meron pang hindi ako na-drawing. 3.
Okay na
How
po.
about on 3? 3, 2, 3, 1, 3, 4 are in G. So, 3, 6 lang and 3, 5. How about in 4? Meron pa ba akong hindi na-drawing sa 4? 4 should be 4, 2, and 4, 1. Right? Okay. So, that's it. So, those are the edges in G bar or G complement. So, how about as a set? So, as a set, kung hindi mo titingnan yung graph, titingnan mo lang lahat ng possible combination ng V. So, these are all the possible combinations of edges. All possible edges. Alright. Now, lahat ng nasa possible edges na wala dito, yun yung mapupunta sa complement. Lahat ng possible edge na wala sa E. Alright. So, nandun yung 1, 2, 1, 3, 1, 6. Kung so, titingnan mo, lahat ng possible edges containing 1 ay 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So, ang matitira na lang, 1, 4, 1, 5. Again, if you're not looking of the graph. Now, how about 2? Lahat ng nakakonect sa 2 ay, syempre, nakuha ko na yung 2, 1. Eh. So, 2, 3, 2, 4, 2, 5, 2, 6. Nandun yung 2, 3. So, ang makupunta rito ay 2, 4, 2, 5, 2, 6. Let's move to 3. Ang mga nakakonect kay 3, hindi ko nakukunin yung 3-1 saka 3-2. Na ano natin yan, nakuha na natin possibility na yon. Siyempre, walang 3-3 ha, kasi simple graph. So, 3-4, 3-5, 3-6. Pero lahat yun nandun. 3-4, 3-5, 3-6. Ay, wala pala. 3-5, wala pala. Sorry. So, 3-5, 3-6. Naduling lang. How about 4? So, we start with 4-5, 4-6, pero nandun na pareho yung 4-5, 4-6. Hindi ko nakukunin yung 4-1, 4-2, 4-3. Na-discuss na natin kanina yung possibility na yan. Alright. Let's go to 5. So, ang mga possible connections sa 5 ay 5-6 lang. Pero nandun yung 5-6. Sa 6, wala rin. Na-discuss na natin lahat ng nakakonekta sa 6. So, that's it. So, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. May kulang tayo. Ano hindi ko na-lista? 2, 5, 2, 6. Hindi ko na diretso sa 6 kanina. Yun na pala. Ulitin natin. So, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay. 2, 3. Nandito. 2, 4, 2, 5, 2, 6. 3, 4 nandito, 3, 5, 3, 6. 4, 5, 4, 6 nandito, 5, 6 nandito. So, wala na. So, okay na yan. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So, tama. We have 7 edges. All in all, ilan ba ang possible edges? Ilan ba laman nito all in all? How many elements does V squared have? All possible edges with 6 number of vertices. Can you guess kung ano ang number of possible edges in V squared? So you have 6 vertices, tapos you connect all of those vertices, meaning it's a complete graph on 6 vertices. So how many edges are there? Sige nga. Nangyari. Kanina, umpisa niyo sa 1. Ano ba mga possible connection sa 1? Ilan ang possibly connected sa 1? Ilan ang edge na nako-connect kay 1?
5 po.
5. Very good. Connected 5. How about kay 2? Yung hindi pa nabibilang kay 1. Ilan na lang ang natitirang nakakonect kay 2?
4 po.
4 na lang. Kasi yung isa nakakonect na kay 1. Diba? 3. Yan na nakakonect kay 3 na hindi pa nakakonect kay 1 tsaka kay 2.
3 po.
3. Kay 4, kay 5, kay 6. So, you get the pattern already. Pagdating kay 6, nabilang na lahat. Nakakonect na lahat kay 6. So, ilan lahat yan? The total. And then 1 plus 2 plus 3 plus 4 plus 5.
15 po.
15. So, dapat ang total number of edges mo, counting the complement NG, are 15. 1, 2, 3, 4, 5, 6, 7, 8 plus 7. Indeed, 15. Para ma-check mo kung tama ka. Alright? Assignment. How many edges are there in general for a complete graph with n vertices? How many edges? Ito na yung clue. Anong formula? Anong formula pagka gusto mong hanapin yung number ng vertices ng complete graph? What's the formula? Yan. So, tingnan nyo. Try to do it for 7, for 8, and then tingnan nyo kung makukuha nyo yung pattern. Alright. Since you already know number theory, so dapat sa number theory, ma-prove nyo na tama yung pattern nyo using induction. Yan. Okay. LG naman tayo, LG. The line graph. So, drawing natin yung LG. So, this is G. This is still G. So, how do we draw LG? So, again, the vertices now are different. The vertices in LG are the edges in G. Edges in G. So, ito na yung magiging vertex set mo. Yan. 1, 2, 1, 3, 1, 6. So, let me draw here. So, ilan dapat? 8 dapat. So, 1, 2, 3, 4, 5, 6, 7, 8. So, let me represent those 8 vertices as, lagay ko dito, 1, 2, 1, 3, 1, 6. Kahit saan mo ilagay, okay lang. 2, 3, 2, 4, 2, 3, 2, 4, 3, 4, 4, 5, 3, 4, 4, 5. Alright. Ano ba? Ito pala. 4, 6, and 5, 6. Kulang ako? 1, 2, 3, 4, 5, 6, 7. 7 lang pala. Kulang ako ng isang edge. Ibigyan natin ng isa pa. Ayan. 4, 6, and 5, 6. So, those are the edges in V right? In G, which will now be the vertices of LG, the line graph of G. Now, how do you connect these vertices? So, as an edge, titingnan mo siya as an edge in G. Pag yung edge na yon connect adjacent, as a vertex, adjacent din sila. For example, 1, 2, and 2, 3 are adjacent as edges. So, as vertices in LG, dapat adjacent din sila. Yung 1, 2, tsaka 2, 3. So, there should be a line connecting 1, 2, and 2, 3. Let me change the color so that it's more obvious. Okay? 1, 2, and 2, 3. Now, yes, question.
Pero sobra po yung yung edges po.
Alin ang sobra ko?
Yung 2-4 po.
Sorry, alin?
2-4 po, sir.
2-4. Wala ba yung 2-4? Nagkamali ba? Nga, wala yung 2-4. Yes, correct. So, tama na pala kanina. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 10. Tama na pala kanina. Mali lang yung nasulat ko. So, let me remove 2-4. Alright. Thank you. So, again, we have 1, 2, and 2, 3 as adjacent vertices, meaning there's an edge between 1, 2, and 2, 3. Now, can you tell me, without looking at the graph of G, how can I decide whether or not two vertices in LG are adjacent? So, how do I determine the edges in LG without looking at the graph? One example is 1, 2, and 2, 3.
Ano po, yung dulong number po nung isa, tas yung umpisang number po nung isang vertex po.
Ay ano? Yung dulong number I at yung isang number I
Magkaparehas po.
magkaparehas. Okay. So that's a good observation. But in general, 1, 2, and 2, 3 are being written as a set. In general, di ba? 1, 2, 2, 3. So that's an edge which becomes a vertex here. So pwede ko siya isulat as 2, 1. So it can be written as this is the same as 2, 1. So i-tweak lang ng konti yung definition ng edge dito sa LG para masatisfy pa rin yung 1, 2. Kasi it doesn't necessarily be on the first or on the second position. Kasi 1, 2 is the same as 2, 1. So how do we determine whether 2 points here in LG are connected? If
Sir, pag may if, two number po silang kapareho.
ayun. So, in any position, basta may kaparehong number. Right? Yung pagkaka-represent mo ng edge. So, kasi, pag may magkapareho kang number, that would mean as an edge, they are adjacent. Diba yun ang definition ng adjacent? Adjacent edges are edges with a common vertex. So, since these are vertices actually of the edge in G, then when you have a common vertex or when you have a common number, then that's an adjacent edges, which in case in the line graph will be connected vertices. All right, so anong nakakonect sa 1, 2? So where do I connect? 1?
1, 3, 1, 6 po.
Okay, very good. 1, 3 pa, tsaka 1, 6. How about in 1, 3? Bukod sa 1, 2, meron pa bang ibang nakakonect sa 1, 3?
2,
So,
3 po.
it should be connected.
4.
2, 3, yes. 3, 4, very good. Meron pa ba? So, lahat ng may 3. Okay. For 2, 3, lahat ng may 2, tsaka lahat ng may 3. For 3, 4, lahat ng may 3, lahat ng may 4. This is 4. This is 4. Ano pa? Ayan. For 4, 5, lahat ng may 4, lahat ng may 5. So, this is 5. Meron pa bang may 5? Wala na. May 4, 4, 6. 4, 4, 6. Lahat ng may 4, 5. Okay, okay na. 4, 6. So, lahat ng may 4, saka lahat ng may 6. So, ito may 6. Tama? Ito, 5, 6, saka 4, 6. Alright. Meron pa ba ako nakalimutang dapat magka-connect? 1, 6. Saka 1, 3. 1, 1. Okay. Meron pa? Paki-double check. So, yung 1, lahat na nakakonect sa 1. Tsaka lahat na nakakonect sa 6. 6, 6. Yung 5, may 6. May 5. Okay. So, I guess that's all the edges of LG. So, you can just write here the vertices. So, as vertices, you write this as okay. So, you write this as a 2-element subset. So, that's 1, 2, 1, 3. At this point, okay pa siyang isulat in this representation kasi single digit pa lahat. So, pag nakita ka ng 1, 2, that means it's an edge in G. But in LG, it's a vertex. So, 1, 2, 1, 3, 1, 6, 2, 3, 5, 6, 4, 6, 4, 5, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then you can just write the edges are, this time you need to write it as a 2-element subset kasi nakakalito na when you just write them together. So, hindi na pwede. Kailangan mo nang isulat as 1, 2, 1, 3. 1, 2, sorry. 1, 2 muna. 1, 2, and then, nakuha ko na yung 1, 3, so 1, 6. So, ano pa mga connected sa 1, 2? 2, 3. So, 1, 2, 2, 3. Yun lang, yung tatlo na yun. So, 1, 2, 3. And then you just write all of them. Okay. So, I'll leave the rest to you as an exercise. Okay. Tuloy natin. About graph pa din. So, degree of a vertex. So, what do we mean by a degree of a vertex? So, for a given graph, the set of neighbors of a vertex B denoted by n of B or simply NV, minsan nilalagay natin yung sub G pag maraming graph na pinag-uusapan para we know which particular graph we're talking about. So, in general, if we're just talking of a simple or a single graph, so we can just denote this as NV. So, NV is the set of all vertices in V that are adjacent to V. So, all X in V such that Vx is an edge in E. So, for U subset of V, the neighbors of the set U are the set of neighbors in V minus U. So, you do not include any set in the U as neighbor of U. Sometimes kasi, two vertices might be neighbors of each other, but both of them are in U. So, we only consider those neighbors that are outside U. So, the neighbors of a set U are all the neighbors of the set, all the neighbors of each vertices in U that are not in U. Yan. So, yung mga neighbor ng mga points na nasa U, pero yung neighbor na yon dapat nasa labas ng U. Okay. So, those are called neighbors of U. Now, the degree of V, or sometimes called the valency of V, denoted as D of V, is simply the number of value or edges, number of edges at V. So, that is the same actually as the number of neighbors ni V or E of B. So we will denote that in general as D. So again, the degree of a particular vertex is the number of edges adjacent to it. So kaya nga in Facebook, mas mataas yung degree ng isang tao, meaning mas maraming nakakonekta sa tao na yun. So yun yung ibig sabihin ng degree. Now, a vertex of degree 0 is isolated. Because if you have degree 0, meaning walang edge na na-connect sa'yo. So you're an isolated point. And a vertex of degree 1 is an end vertex. Meaning, isa lang yung nakakonect sa'yo and no other. Sometimes, it's called an end vertex in the point of view of a path. Kasi, later, when we discuss about path, yung nasa dulong point, ang degree nun, isa lang. Pero anywhere inside the path, ang degree is greater than 1. Now, small delta G denotes the minimum degree of G. That means if you get all the degree of each point, you get the lowest degree that you have, then that's your small delta G. On the other hand, the capital delta G, so the small delta G is this one. Nabura. So this is the small delta, and this is the capital delta. Yan. So, those are Greek letters for D, yung delta, Greek letter ng D. So, pag small delta, minimum, pag capital delta, maximum. So, all you need to do is to count the degree of each vertices, and then whatever the lowest value is the minimum, and whatever the highest value is the maximum. So, the lowest value will be your small delta, the highest value will be your capital delta. All right. Now, there are some graph that where the degree of each vertices are the same all throughout. These are called regular graph. Classical example of a regular graph is a complete graph, di ba? For example, a complete graph on 3 vertices. So, on each vertices, the degree is 2. So, D here is 2 for all the vertices. A complete graph of order 4 is this one, right? So, all vertices is of degree 3. There are 3 edges incident to each of the vertices. So, a complete graph in n vertices has what degree? Complete graph of n vertices. In general, pag n vertices, ano ang degree ng graph na yun? Anyone? Pag K3, ang degree 2. Pag K4, ang degree 3. So, pag Kn, ano ang degree?
N-1 po.
Okay. Okay, very good. Yes, that's n-1. Alright. So, yun yung degree. So, again, if it's regular, meaning lahat ng mga edges, pare-pareho ng number of lahat ng mga vertices, pare-pareho ng number of edges connected to it. Yeah. Okay, in general, if you count the total number of degrees for each vertices, and you divide it by the total number of vertices, that's the average degree of G. So we denote that as D of capital G, degree of the graph. So when we say degree of the graph, that's the average degree. So that's why for a regular graph, of course, the average degree is the degree itself of the regular graph. Kasi yun nga yung number of degree for each vertices. So if you all add them all and you divide it by V, so D pa rin yung makuha mong sagot. Okay. But in general graph, of course, hindi laging equal yung mga degree ng kada vertices. So, in that case, we have the inequality na Hindi ko nasulat dito. So let me write that. We have the inequality, the degree or the average degree is always between, of course, the minimum degree and the maximum degree. That should be obvious. So for a regular graph, they are all equal to K, to the valency of the graph. For a regular graph, equal natin. Okay. Now, in general, if we add all the degrees of the vertices, so let's say we have a graph of order n with vertices v1, v2 up to vn, and we add all the degrees for each vertices, the answer is actually twice the number of edges. Twice the number of edges. This is called the handshaking lemma. Why is it called the handshaking lemma? Because this is the same of the number, for example, you have a gathering. Okay. So you have n number of people in a gathering. And then you ask these n people, okay, shake the hand of anyone you want to shake. So you meet some people, you shake their hand. So probably there are people that you won't shake, probably there are people that you shook hand with. Now you ask each of them, okay, how many hand have you shaken with? So that will be equivalent to asking the number of edges connected to that particular person. So a handshake is equivalent to an edge, right? So ang sasabihin niya is the number of degree. Nung kung i-treat mo siya as a vertex. So if you now add all of their answers. So for example, si person 1 nakipag-handshake siya sa 3. Si person 2 nakipag-handshake siya sa 5. And so on and so forth. If you add all of them, the total number is actually twice the number of handshakes na nangyari. Why is that so? Kasi syempre, for every time you shook hand with another, there are 2 handshaking. Tama? Yung hand mo, tsaka yung hand ng ka-shake mo. And if there are m number of shakes na nangyari, then twice that will be the number of hand na nag-shake. Which is really the number of degrees, the total sum or the sum of the individual number of degrees for each vertices. Yan. So, yun yung ibig sabihin ng kaya siya tinawag na handshaking lemma. Because that's the total number of hand na nakipag-shake. Twice the number of. That's easy to visualize, ha. You just look at 2 different individual. This is person 1, this is person 2. Tapos pag nag-shake sila, so you have an edge. BIBJ. So that particular edge will contribute to vertices. Tama? Ibig sabihin, pag binilang mo yung number of edge incident to this, tsaka yung number of edge incident to this, meron ka na agad 2. So for each edge, nagko-contribute siya lagi ng 2 dun sa sum. Right? So kung si B3, kung si VI, meron pa siyang ibang ka-handshake, let's say meron pa siya ritong BL or BM, so meron ka na namang another edge dun. Right? So yung edge na yon, so ang incident nito magiging 2 na, ang incident nun magiging tig 1. Pero kung ang titingnan mo lang yung edge, that means meron kang dalawang endpoint. Yung endpoint ni edge 1 tsaka endpoints ni edge 2. So for each edge, lagi mong kinakount 2, yung number of degree. So for every edge, meron kang makakount na 2. So pag tinotal mo lahat yon, that's the total number of degrees ng mga vertices. But in terms of the edges, that's just twice the number of edges, 2m. So the total sum of degree is the same as twice the number of edges. So that's a simple fact about graph. So for any graph that is, since each edge contribute 2 degrees in the sum, the total sum of the degrees will be twice the number of edges. Now, here's my question. And I leave it as an exercise for you to ponder upon. What is the maximum number of edges can a graph of order n have? Ilang number of edges ang maximum na pwedeng meron ng isang graph. Okay? So that's the same as saying, pag meron kayong gathering, ilang maximum handshake ang pwedeng mangyari. Kailan mangyayari yung maximum handshake? Pag lahat, hinandshake niya yung the rest of the group. So, kailangan bawat isa, i-handshake lahat ng nandun. So, meaning, yun na yung maximum handshake, di ba? O, ilan lahat yun? If there are n number of people doing the handshakes. Yan. So, that's the same as answering my question. What is the maximum number of edges that a graph can have? If the graph has total n number of vertices. So, for example, pag tatlo, madali lang tingnan yan. I-handshake mo yung bawat isa. That's the maximum number of edges. Pag apat, i-handshake mo bawat isa. That's the maximum number of edges. So, you generalize the question. So, dapat at this point, alam mo na kung anong bibilangin mo, kung edges ng anong graph. Yan. Okay? So, I'll leave that to you to ponder upon. So, a vertex is called even if the degree of that vertex is even and odd if the degree is odd. So, the parity of an edge is the same as the parity of its degree. Meaning, kung ang degree or the number of edges connected to it is odd, then we say that that vertex is odd. If the degree or the number of vertices or edges rather connected to it is even, then we say that that vertex is even. Okay. So we have another nice property of a graph. Every graph has an even number of odd vertices. Ulitin ko, every graph has an even number of odd vertices. So kung magdodrawing ka ng graph, tapos bibilangin mo yung mga vertex na may mga odd degrees. Lahat yun, pag tinotal mo, even number of vertices yun. For example, yung triangle natin, yung K3 natin, this is K3. How many number of vertices or what is the degree of each vertices? Lahat yan, 2. So, the number of odd vertices is 0, which is even. For K4, the number of or the degree of each vertices is 3. And how many vertices has degree odd? All of them, which is 4. And 4 is an even number. Let's take another look. Let's take another example of a graph. Yung kaninang graph natin, kung naalala nyo pa. Yan. Okay. So, ito, ano ang degree nito? 1, 2, 3. Ito, 2. Ito, 3. Ito, 3. Ito, 3. Ito, 2. Pag binilang mo lahat ng odd degrees, lahat ng vertex na may odd na degrees, 1, 2, 3, 4 vertices. There are even number of vertices na add ang degree. Kahit anong graph ang i-drawing mo. Let's have another example. Yung kaninang graph na isa. Ayan. Okay. Ito, 2. Ito, 1. Ito, 1. Ito, 2. Ito, 2. Ito, 0. So, ilan doon ang odd number yung degrees? Itong vertex na to, tsaka yung vertex na to, dalawa. 2 even number of odd vertices. So, for any graph, that's true. There are always even number of odd vertices in any graph. Why is that so? That's easy to visualize as well. Again, by formula nung handshake rule natin, 2m, twice the number of edges, is the sum of all the degrees. Pag in-add mo lahat ng degrees ng lahat ng vertices, 2m yung sagot. Now, kung titingnan mo yung vertices by its parity, so i-add mo lahat ng odd edges, i-add mo lahat ng even edges. So lahat ng odd edges, saka lahat ng even edges. Alright. Now, as a number, kumbaga, ina-add mo dito lahat ng even ang degrees. Ina-add mo dito lahat ng odd ang degrees. Ayun yan. Okay. kung titingnan mo to as a number ha, kumbaga inad mo na lahat. Siyempre, puro even yung ina-add mo eh. So, even number yon. Ha? Puro even yung ina-add ko eh. So, even number plus even number is even. So, no matter kung ilan man sila, pag inad ko yung mga number na yon, even pa rin ang lalabas. Alright. So, ibig sabihin nun, yung even na to, minus yung even na to, even pa din yan. Di ba? Even pa din yan. Kasi even number minus even number. Pero equal yan dito. Inad mo, alin ba to? Yung inad mo lahat ng mga odd degrees. Di ba? Ang degree nun, 3. So that's 3 plus 3 plus 1 plus 5. So lahat ng mga number dito, puro mga odd number. Walang even number dyan. Individually, puro odd yan. Either 1, 3, 5, 7, and so on. Alright. Pero yung ka-equal niya, even. So, sum ng mga odd number equal sa even. Kailan lang pwedeng mangyari? Na ang 3 plus 3 plus 5 plus 5 plus 7 plus 7 plus 9 plus 9 plus 11 magiging even. Kailan lang mangyayari yun? Siyempre, pag meron kang even numbers of addends, di ba? Halimbawa, 3 plus 3 plus 9. Kung tatlong add ang inad mo, yung magiging sagot, add. So, para maging even ang sagot, kailangan either dalawa or apat or, ibig sabihin, dapat even numbers, meron kang even numbers na addends. Ano ba madaling i-explain? So, lahat ng mga add lahat ng mga odd number na pinagsasama-sama mo, dapat individually, ang total nila ay maging even, di ba? So, individually, pag binilang mo sila isa-isa, dapat ang total number of odd numbers, dapat even. Para ang maging total sum, even pa rin. So, for example, 3 plus 3 plus 5. Meron kang addends. Kaya ang magiging result niyan, magiging add din yan. Kasi addends eh. Pero kung 1 plus 3 plus 5 plus 7, 4. So, even na addends. Pag inad mo yan, ang magiging sagot, even pa rin. So, restricted na dapat ang maging sagot even. So, ito lang yung case na pwedeng mangyari. Meaning, you're adding even numbers of odd degrees. You're adding even numbers of odd degrees. Or in a simple statement, there are even numbers of odd vertices in any graph. So, lagi yan. Okay, more definition about graph. Let G be a loopless graph with V written as, or the vertex set, V1, V2, V3, and so on, up to Vn. And the edge is written as E1, E2, up to En. The adjacency matrix of G, denoted by A of G, is the n by n matrix in which the Aij entry is the number of edges in G with endpoints B1, Bi, Vj. So, gagawa ka lang ng matrix na ang magiging entry, ika-count mo lang yung number of edges between the two vertices. So, halimbawa, ang entry ng 1, 1 is 0 because 1, 1 meaning you're taking vertex 1 and vertex 1, which is the same vertex. Tama? So, there can be no loop, kaya walang vertex connecting V1 and V1. Okay. How about the entry 1, 2? So, the entry 1, 2 means the number of edges connecting V1 and V2. So, kung they are connected by 1 edges, then the entry V1, 2 will be 1. Kung 2, 2. Kung 3, 3, and so on. If it's a simple graph, syempre either 1 or 0 lang. If it's a simple graph. So, that's what an adjacency matrix is. Ano naman yung incidence matrix? The incidence matrix, denoted by Mg, is the n by m matrix in which the Mij entry is 1 if Vi is an endpoint of Ej. So, tinitingnan mo naman ngayon kung yung vertex I ay endpoint ng edge J. So, papangalanan mo yung vertex mo, B1, B2, B3, and so on, up to Bn. Papangalanan mo yung edges mo ng E1, E2. So, yung matrix, pagtingin mo sa matrix, pagka incidence sila, 0. 1. Pagka hindi sila incidence, 0. Okay? Let's have an example para mas madaling makita. So let's have this example. This is the same as the 7-bridge problem, if you remember. So the edges are numbered V1, V2, V3, V4, or for simplicity, let me just call it 1, 2, 3, 4. Tapos, ang edges natin, there are 2 bridges from 1 and 2. That's E1 and E1 prime. There are 2 bridges connecting B2 and B3. That's E2 and E2 prime. Kung naalala nyo pa yung 7-bridge problem, there are total of 7 bridges, di ba? Now, on V1 and B4, B2 and B4, V3 and B4, there is 1 bridge connecting the 2 respectively. Okay. So, how do we write or how do we construct the adjacency matrix? So, the adjacency matrix is a matrix that tells us whether the 2 vertices are adjacent. So, that tells us whether the 2 vertices are adjacent. So, meaning, you construct, so imagine that this is vertex 1, 2, 3, and 4. And then this will be vertex 1, 2, 3, and 4. So, all you need to do is to ask, vertices 1, 1, are they adjacent? Kung yes, 1. Kung no, 0. Rather, ilan yung edges connecting them? Okay? Yung adjacency matrix. So, let's start. 1, 1 meaning vertex 1 to vertex 1. Of course, they are not connected since we eliminate the possibility of a loop. So, in the same manner, 2, 2, 3, 3, and 4, 4 will always be 0. Wala tayong loop. Pag may loop, may value yan. Okay. Now, 1, 2 meaning vertex 1 and vertex 2. How many bridges are connecting them? There are 2. So, 1, 2, magkaka-entry ka ng 2. But, the connection between 1, 2 is the same as the connection between 2, 1. So, same entry ang 2, 1. Alright. 1, 3. So, 1, 3. Is there an edge connecting them? Wala. So, 0. So, again, 3, 1 is the same connection as 1, 3. So, yung 3, 1, 0 din. 1, 4. Is there a bridge connecting 1 and 4? Yes. Ilan? Isa. So, 1. Is there a bridge connecting 2 and 3? This is 2, this is 3. There are 2 bridges. So, 2. How about 2 and 4? Yes, may isa. Now, again, the bridge between 2 and 3 is the same as the bridge between 3 and 2. Nga. So, meaning, ang entry ng 2, 3 is the same as 3, 2. Ang entry ng 2, 4 is the same as 4, 1. Right? Okay. Now, ano lang hindi ko na fill upan. Yung 3, 4. Is there a bridge between 3, 4? Meron, may isa. That's your adjacency matrix. So, right away, from the adjacency matrix, you should be able to tell which vertices are connected and which are not. If the entry is 0, then there is no connection between them. If the entry is 1, then there is one connection between them, and so on. If the connection is k, then there are k different connections between them. So it's another way of looking at the graph without actually picturing what the graph is. Ayan. Now, how about the incidence matrix? So the incidence matrix is an n for the number of vertices, m for the number of edges. So this should be a 2 by 7 at 4 rather, 4 by 7 graph. So let me number it 1, 2, 3, 4 for the number of vertices, and 1, 2, 3, 4, 5, 6, 7 for the number of edges. So ganun ulit. If the vertex is incident to that edge, write 1. Otherwise, write 0. Okay. So let's start with vertex 1. So vertex 1 is incident to which vertices? So I'm writing here, ito yung 1, 2, 3, 4, 5, 6, 7. Kumbaga, i-fix ko na yung arrangement nun. The matrix will depend on how you arrange your edges. So once na in-arrange mo na yung edges that way, that should be fixed all throughout when you construct your matrix. Hindi pwedeng pabago-bago. Okay. Okay, so saan connected si vertex 1? In our matrix, this vertex 1 is connected to E1, so that's 1, E1 prime, that's 2, and E3, which is 5. So 1, 2, and 5. So you put 1 on 1, 2, and 5, the rest 0. Alright? Next, the vertex 2. So vertex 2 is connected to many bridges, right? Except E3 and E5. So just except E3, which is 5, and E5, which is 7. So 5 is 0, 7 is 0. The rest, it's connected to, or it's adjacent, or incident rather, wrong terminology, incident to 2. Vertex 3, it's incident to E2. This is E2, number 3. E2 prime, that's why it's very important to arrange them and number them accordingly. Kasi nakakalito pag wala yung ordering. And E5, which is this one. E5, not this one. E5 is this. So, 3, 4, and 7. 3, 4, and 7. The rest, 0. Alright. Now, how about 4? The vertex 4 is connected to, this is vertex 4, E3. So, where's E3? This is E3, E4, and E5. So, vertex 4 should be connected to 5, 6, 7. So, 1, 1, 1 here, 0, 0, 0, 0 here. And this is actually how you store a graph in a computer. You don't store, again, as I've said a while ago, you don't store the value, the drawing or the physical representation. You store it as a set. Now, this is a simpler way to store this set. From the adjacency matrix and the incidence matrix alone, you should be able to identify the graph itself. From here alone, dapat makuha mo na kung ano yung mga vertex connected to another vertex, right? And how many edges are connecting those vertices. So all the information of your graph are being stored in these two simple matrices, the adjacency matrix and the incidence matrix. And you should be able to visualize your matrix, your graph just by using your adjacency or incidence matrix. Dapat, kung given yung graph visually or as a set, dapat kaya mong i-construct yung adjacency tsaka incidence. Kung given yung adjacency tsaka incidence, dapat kaya mong i-construct yung graph mo. For example, mamaya natin yan. For example, let's have the adjacency matrix this way. So, as you've seen a while ago, an adjacency matrix is a symmetric matrix. Well, I know already that you pass linear algebra, so dapat alam niyo na ibig sabihin ng symmetric matrix, ha? Kasi, di ba, prereq natin ng linear algebra. So, we'll use more of linear algebra later. So, for example, let me number this 1, 2, 3, 4, 5. And then, so, I should have a 5 by 5 matrix here. 1, 2, 3, 4, 5. So, I'm labeling my matrix accordingly. So, of course, if this represents an adjacency matrix, then the main diagonal should be 0 kasi we don't have a loop in this particular adjacency matrix. So, let me give some value here. Let's say I have 1 here, 0 here, 2, 0. So, it should be symmetric. So, this is 0, no, rather, it's 1, 0, 2, 0. I'm just playing around with values. Let's say we have 2 here, 0 here, 1 here. Okay, 2, 0, 1. 1, 1. 1, 1, 0, 0. Okay. Now, that's an adjacency matrix. So, the goal is, how do we visually represent our graph? So, that should be easy. Using the adjacency matrix alone, we can now identify the edges. So, we just have to draw 5 vertices. So, let's call it vertex 1, vertex 2, vertex 3, 4, and vertex 5. So, according to our adjacency matrix, vertex 1 is connected to vertex 2 and 4. On vertex 1, there's one connection. Between 1 and 2, there's one connection. Between 1 and 4, there's two connections. So, okay, so let's do that. 1 to 1 connection, right? 2 for 2 connection. So, let's say this is your one connection and your other connection. Vertex 2 is connected to 1, of course, so we've already drawn that. And it's also connected to vertex 3 with two connections. So, two connections on vertex 3. And then, it's also connected to vertex 5 with one connection. These intersections here does not denote any point, ha? Again, topologically, there's no intersection there. You can always think of it as something na nakaangat or nakababa. So, hindi nag-intersect doon. Our points are just the vertices 1, 2, 3, and 4. And you don't create any other point other than those vertices. Kasi, we can always draw naman the... What's happening? Wait. You can always... We can always draw the edge outside. If you want to be technical about intersection, di naman ito yung edge, right? Between 2 and 5. Okay. What's important is there is an edge between 2 and 5. Now, vertex 3 is connected to vertex 2. We've already drawn that already. Ito na yun, dalawang connection. And it's also connected with vertex 4 and vertex 5 with one connection. So, 1 for 3, 1 for 5. And then vertex 4 is connected, of course, we already know it's connected to vertex 1, 2 connection, vertex 2, 1 connection, vertex 3 rather, 1 connection, and nothing else. Alright. Vertex 5 is connected to, of course, we've already drawn that, it's connected to vertex 2 and vertex 3. So, that will be your graph. So we were able to construct our graph just by looking at the adjacency matrix. Okay? And that should always be the case. Given the adjacency matrix, you should always be able to reconstruct your graph. Now, but if you only have the incidence matrix, now for the incidence matrix, the problem is you won't be able to construct the graph if the graph has multiple or parallel edges. Because the incidence matrix only tells you whether a vertex is incident to an edge. Right? But of course, if you have distinct edges, then you should be able to also draw or construct the graph. For example, if we construct our graph in reverse from the incidence matrix, how do you know that there are parallel edges? If you look at this 2 and 3, this edge and this edge. Sorry. Wait. Did we get? Yeah. We get it. Rather, let's look at this is edge 1 and this is edge 2. That's edge 1 and edge 2. But if we look at edge 1 and edge 2, they are both incident to two same endpoints, endpoint 1 and endpoint 2. So when we construct these two edges from vertex 1 and vertex 2, so one is incident to edge 1, and then the other point that this edge is incident to is this. So that means this 2, 1 will construct one edge. So vertex 1 and vertex 2. Vertex 1 and vertex 2. On the other hand, this edge will be constructed using also vertex 1 and vertex 2. So that means we can construct another edge on vertex 1 and vertex 2. Now, on the other hand, the third edge is constructed using vertex 2 and vertex 1. So vertex 3 is, let's say we have a vertex 3 here. So there should be an edge connecting that vertices according to our incidence matrix. Vertex 4. Also, connecting vertex 2 and vertex 3 is edge 4. So this is E1, E2, this is E3, and then there should be another connecting 2 and 3. Edge 5 is connecting vertex 1 and vertex 2. Rather, vertex 4. So there should be another vertex, so let's say 4, connecting 1 and 4. So for these two vertices. Edge 6 connects vertex 2 and vertex 4. Vertex 2 and vertex 4. And then edge 7 connects vertex 3 and vertex 4. So we were able to construct back the original, they are isomorphic, right? Using the incidence matrix. So again, because in reality, adjacency matrix and incidence matrix are two different matrix representation of the graph. From the graph, you should be able to construct the adjacency and the incidence matrix, and vice versa. From the adjacency and the incidence matrix, you should be able to construct the graph. Okay. Question. Okay, walang tanong. So, I'll leave this as an exercise. Construct the adjacency matrix and the incidence matrix of this graph. So, this is the same graph that we've been using as an example before. All right. So, this is another example of a graph. An n cube. This is a very interesting graph. What is an n cube? Denoted by q sub n. An n cube is a graph whose vertex set is the set of all n tuples of zeros and 1, where two n tuples are adjacent if they differ in precisely one coordinate. Okay. If they differ. So, we're talking of n tuples. Okay? Ano ba yung n tuples? Yung ganyan. X, Y, Z. That's 3 tuples. Or in a more nicer representation, X1, X2, up to Xn. So that's an n tuples. Okay. So for n equals 1, we have Q1. Q1 is simply a 1 tuple, a graph whose vertex is the set of all 1 tuple of zeros and 1. Well, if you're a 1 tuple of zeros and 1, meaning you only have one coordinate. So either 0 or 1. That's your vertex set. Either 0 or 1. Right? So you have an edge if the two tuples differ in precisely one coordinate. So the coordinate of the first point is 0 and the coordinate of the first point is 1. So this is the point 0, this is the point 1, and that's your edge. So that's a Q1. So this is Q1. Well, not a very interesting graph, but later you'll see why it's called a cube, an n cube. So let's proceed to n equals 2. So this is Q2. So what are the vertices of Q2? So this time it's at 2 poles. A coordinate with 2 coordinates. Yan. At 2 poles with 2 coordinates. Alright. So what will be the coordinates? So the coordinates will be either 0, 0, right? 0, 1, 1, 0, or 1, 1. So you now have 4 vertices, right? 4 vertices. So let me draw the vertices. So this is vertex 0, 0. For simplicity, I will just write vertex 0, 0 as this, meaning it's an ordered pair 0, 0. All right? The first number is the first coordinate, the second number is the second coordinate. Again, there will be no confusion since we only have 2 numbers, 0 and 1 involved. So let me draw here, let's say the point 0, 1. And here the point 1, 0. I'm already simplifying. And here the point, let's say 1, 1. So those are the 4 points. Now, when will they be adjacent? If they differ in exactly 1 coordinate. Okay, pag magkaiba sila ng isang coordinate. So, dalawa lang naman yung coordinate. So, dapat magkamukha sila sa isa tapos magkaiba sila sa kabila. For example, 0, 0 and 0, 1 differ only on the second coordinate. So, there should be an edge. There should be an edge joining them because they differ on the second coordinate. 0, 0 and 1, 0 differ on both coordinates. So, there is no edge connecting them. Right? Magkaiba yung first at second. Now, 0, 0 and 1, 1, they differ in both coordinates, so there's no edge between them. 0, 1 and 1, 0 differ in both coordinates, so no edge between them, right? Let me correct myself. 0, 0 and 1, 0, they differ only on the first coordinate. So there should be an edge between them. Tama, di ba? Mali ako kanina, sorry. So they have the same second coordinate. Okay, next. 0, 1 and 1, 1, they have the same second, different on first. So they should be connected. 1, 1 and 1, 0, they should be connected. So there are 4 edges total. Meron pa bang ibang connections na na-miss ko? Now, this is actually a square. Kung aayusin natin yung arrangement ng vertices. Right? I purposely arrange that in a manner na hindi nyo makikita yung square agad. Pero if you arrange it nicely, so how do we arrange it nicely? Instead of that orientation for the edges, let me rearrange the edges this way. Okay. Let me put here 0, 0. And then this is 1x, 0y. This is 1y, 0x. And this is 1x, 1y. So just like doing a Cartesian plane, di ba? Pag Cartesian plane, nandito yung 0, 0, 1, 0, right? In a Cartesian plane. So I'm drawing it in the same manner as how I would draw it in a Cartesian plane. Because they are indeed coordinate systems. All right. So what are the connections? The connections are, I will just rearrange this. So there's a connection between this, and between these two. So that's a square, right? Right. So that's a Q2 or a 2 cube. In general, that's called a 2 cube. Okay, but in geometry, we call that a square. Yan. It's starting to get interesting, right? How about n equals 3? Now, this is a little bit trickier than usual. So, what does Q3 look like? Sorry, let me change the color of my pen. So, Q3 will look like this. So, it should have 3 coordinates, right? So, the coordinates are 0, 0, 0, 0, 0, 1, 0, 0, tapos na yung 0, 0. Right? So, para ang gumagamit ng binary numbers. 0, 1, 0, 0, 1, 1, 0, well, if I add 1, so that becomes 1, 0, 0. 1, 0, 1. Right? Right? 1, 0, 1, and then 1, 1, 1. 0 muna. 1, 0, 1, 1, 1. If you're familiar with binary numbers, that's just binary numbers with 3 digits. 0, 0, 0, 0, 0, 1. So plus 1, 1, 0. Plus 1, 1, 1. Plus 1, 1, 0, 0. Plus 1, 1, 1. Plus 1, 1, 1, 0. Plus 1, 1, 1, 1. I'm assuming you already know your binary numbers. Okay. But if you don't know, you're just creating your coordinate system with only 2 entry, either 0 or 1. So you just have to create this, x, y, z. Either x is 0 or 1, either y is 0 or 1, either z is 0 or 1, and then you get all the possible combinations of 0 and 1 in 3 digits. And these are all your possible combinations. So all in all, you have 8 vertices. All right. 8 vertices. So let's try to construct these 8 vertices as a 3-dimensional coordinate system. So let me draw a guide that we can follow later. 3 coordinate system. Kasi these are just simply the coordinates 0, 0, 0, 0, 0, 1, and so on. Okay, so let me draw 0, 0, 0. Sorry for a very messy blackboard. Let me redraw it. Less messy this time. Yan. 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 So this goes x coordinate, y coordinate, z coordinate. Okay. So this is the point 0, 0, 0. Right? This is the point. So I move 1 on x. So that's 1, 1, 0, 0. Okay. Now, if I move in this direction, right, there's a 1 here. So that's 1, 1. As a coordinate, that's 1, 1, 0. This point, on the other hand, is I move y1. So that's 0, 1, 0. The ordering is x, y, z. Okay, let's go up. So this is 1, 0, 0. And then move 1 unit to the right on x. So this is 1, 1, of course. 1, 1x, right? 1x, 0y, 1z. And then if I move on that direction, 1 unit on the y, that becomes my 1, 1, 1. Right? Tell me if I'm wrong, huh? Now, on the other hand, here, I will move 1 on the y. So that's 1. I'm wrong in this particular value. Right? This should be what? I didn't move on x. I didn't move on x. I moved on y. So this should be 0, 0, 1. So this should be 0, 1, y, 1, z. Right. Okay. So those are our 8 points. Nawa naman? So can you tell me which points are connected? Which points will be connected? So you look at the coordinate. If the coordinate differ by 1 coordinate, then they will be connected. For instance, 0, 0, 1 and 0, 0, 0 differs on the third. So there should be a line connecting them. Right? 0, 1, 0 and 1, 0, 1 differs on the first coordinate. So there's a line connecting them. Right? 0, 0, 1 and 0, 1, 0 differs on the second coordinate. So there's a line connecting them. How about 0, 0, 1 and 1, 0, 0? They differ on the first and the second. So no line connecting them. The requirement, the rule is there's an edge if they differ on precisely one coordinate. So on the position, ha? So these are the rest of the lines. I'll draw them. So they differ on the first coordinate. These two differ on the second coordinate. These two differ on the third coordinate. These two differ on the third coordinate as well. These two differ on the second coordinate. The one at the back, this is 0, 1, 1 and 0, 1, 0 differ on the third coordinate. These two also differ on their second coordinate. These two differ on their first coordinate. And then the one on the back differ on the first coordinate. 0, 1, 0 and 1, 1, 0. So all in all, you have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many edges do we have? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Now, this is the reason why this is called an n cube. This is a 3 cube actually. Right? Can you imagine the cube? Oh, there's a cube. There's a cube. So actually, these are the cube formed by the coordinates 0, 0, 0, 0, 1, 0, and so on. So this coordinate system. So in general, that's called a cube. But we can also draw that in different manner. We've already shown before that this can also be drawn this way. Like this one. Yan. If you still remember. So that's 2 cubes already. That's your square rather. That's your third, fourth, fifth, sixth. So these are 6 faces of a cube. 1 on top, 1 on bottom, 4 on the sides. So this is a cube. Alright, so this is a regular cube with valency 3, right? The degree of the vertices are all 3. Any vertex have degree 3. Okay. So this is an example of regular graphs. So Q1, Q2, Q3. Right. So I've already indicated the vertices. So to indicate the edges, all you need to do is to write the pairs. Okay. Or draw the edges, rather. Kung gusto nyo i-draw or i-write as a graph. Now, for you to ponder upon, laging may ganun exercise. Draw. Siyempre yung susunod, Q4. This is a 4 cube. That's a very interesting graph as well. 4 cube. So that will be a regular graph with 4 valency of 4, meaning each edge is connected to 4 different, each vertices is connected to 4 different edges. Okay? Question? Of course, interestingly, you can also draw the adjacency or construct the adjacency and the incidence matrix of this graph. So, for brevity, I'll ask you as an exercise to construct the adjacency and the incidence matrix for Q1, Q2, and Q3. Medyo malaki na yung Q4, so I'll not ask you with Q4. So, draw AG, so construct rather, AG and MG of Q1, Q2, and Q3. Okay? So those are your exercises. Again, for you to determine if you were able to understand the lesson.